Hi, hello everyone. This is Team Roomba with our pitch 2. So our problem statement is to design a device that can help individuals that are ill or restrained in some way require a certain level of care and attention. We choose arm exoskeleton from our last page to be our final design. And our prototype 2.0 has been improved from the first one in 5 different ways. This is our 5 critical issues: comfort, material, accessibility, mechanic, and uniqueness. For the comfort, the weight from the device will provide an additional load on the arm and will result in additional strain on the shoulder joint. So our solution is that we will attach the extra arm with the shoulder brace. The crossbody strap will disperse some of the weight onto the rest of the arm rather than only on the one limb. Another problem with the comfort is that the weight from the device may cause some of discomfort on the point between the device and the arm. Our solution is that we will put some foam piece inside of our actual arm that will reduce the pressure and provide some protection of the skin.
Having an additional device on your arm like this is a bit strenuous, fatiguing on the body, an additional weight that shouldn't be there. In order to compensate for that, we tried making it as comfortable as possible. We had 2 initial concepts, but we ended up combining the 2. The first of which ended up being the shoulder brace, as seen above. This idea of the shoulder brace would be that the arm would be attached to the shoulder brace, and in turn, the shoulder brace would be attached to the opposite side of the body. This would end up decreasing the load on the arm and on the shoulder joint in general, while providing some comfort and some support in the shoulder joint as well. On top of this, we added foam padding to the device. This was placed in specific points along the device that would decrease the pressure on the skin, and ideally this would prevent abrasions, any form of harm or injury to the user, and overall would increase the level of comfort and usability for the device, making the whole experience much more pleasurable.
Our next problem is material. The material can be too heavy, and we hope it will not causing too much stiffness in the person's hands. And other things that the material needs to have enough strength to be able to withstand 40 to 50 pound items. So our first choice is carbon fibers. But it's too expensive and the carbon cannot flex. And our next choice is aluminum. Aluminum will have enough strength, and it's not too expensive. However, it is not most flexible.
When selecting material, we look at the weight and the strength the material can handle. The material should be strong enough to support a weight of 60 pounds, which is the average weight of a paint bucket. With carbon fiber having the advantage in both categories, it would seem to be the obvious choice. However, the price of carbon fiber is significantly higher than aluminum. Aluminum therefore would be the ideal material to use for the final product. However, for the prototype and the budget constraint that we were given, PLA will just work fine.
Our next problem is accessibility. We want to make sure the X arm is easy to put on because we want to make life easier for our user, not difficult. And we also need to make sure our user will be able to wear this device using only one hand. So our solution is we use Velcro strips and padding to attach the extra arm with user. And we're also thinking about design of device that can open in half like a clamshell, allowing the device to close around the arm.
We tried paying attention to how easy it was to put on the device. Since the user is going to have only one hand to put the device on by themselves, we figured that it had to be simple and easy for the user to put on. We had two different ideas to implement, and we ended up combining the 2 to make a proper solution. We included a clamshell design in which the top of the casing encloses the arm, and we included Velcro straps that would help secure the arm in place for a better fit and feel. As you can see in the video, it's pretty easy to do with one hand, and this would reduce the necessity of another individual to help get you in and out of the device. In total, the time to put on the device was about 40 seconds, give or take.
The next problem is mechanic. Our first idea is hydrophilic. A hydrophilic will be mounted from the bicep to the forearm. There would need to be a pump mounted to the back of the user to allow for the movement of the fluid and a power source to power the device. Our second idea is electrostatic motor. An electrostatic motor will be placed at the elbow joint, which will be engaged to the movement. It can sense the motion in the arm and help lift the object.
The mechanism we decided to use is a kind of pulley. It would have a motor attached somewhere on the shoulder, which would then have a wire attached to somewhere on the wrist. Once the motor is activated, it will retract and coil the cable. This movement will assist in lifting anything heavy and will allow the user to activate the muscle while simultaneously getting assistance from the mechanism.
Last but not least, the uniqueness of our design. Would it make it so special compared to other robotic hands and exoskeleton out there? Our design isn't to make a robotic arm that can help you do all the work. Our design is aimed to focusing only one function, help a person lift weight, such as a 5-gallon bucket of paint.
This device isn't meant to lift everything. It has one specific task in mind. It's meant to assist in lifting anything between 40 to 60 pounds above 90 degrees. It allows for supination and pronation of the arm and is meant to assist in returning to normalcy. Our test user suffered an injury that limited the strength of the arm. It is supposed to assist the user lift up certain amounts of weight while still allowing the activation of the muscles.
Combining all this, we have our actual arm 2.0. If you have any question about our actual arm 2.0, feel free to ask us. Thank you.